Okay, in today's class, I'm gonna go over 1.3 and 1.4 first. So today's goal, second here, 1.3. In 1.3 is talking about direction field. Direction field is a way to figure out solution of differential equation graphically. Okay, so before we gonna deep dive to the analytic solution, which is mathematically figuring out solution differential equation. Before we doing that, we want to see other way, graphical method and numerical method. So this is direction field is the graphical method for solving differential equation. So just consider the differential equation dvt over dt. So this is v is unknown function, and then function of t. You may say that t is a time, okay, and the a times v of t plus b. So a and b are real numbers, and then v of t unknown functions. So this is the you know what, the first order, right? So first order, and then ODE, and then linear too. Okay, so yeah, and then A and B are real number belong to that symbol means belong to. A and B belong to the set of real number. Okay, but now when you take a look at the left hand side, which is V prime, right? The derivative of V with respect to. So since this is derivative, we can say that one represents slope of V of t, right? So this guy, we can say the slope of V of t, right? At point t, right? Point t, right? Okay. So now yeah, definitely we don't have any idea how to find the V of t, but probably we can set V of t as fixed point, fixed number. So for given you know, number for V of t, value of V of t, I mean, and then A and B are given, we just assume that, then we can figure out the slope of V of t. So for example, let me give you an example. So here is this time step here, and let's see. So this is a V, okay? So there's a 1, here's a 2, and that's too narrow, sorry. So it's a 1 and 2 and 3. Okay, I don't know. You know, I don't know the definition of V of t, but possibly V could be 1 and 2 and 3, right? So when t equals 0. And the result here is 1, 2, and 3, and kind of time step, right? So at this point, for each point, it's kind of grid point. Okay. A second. Like this. So when v equals 1 at t equals 0, then what? The dv dt going to be a times b plus, oh, give me a second. I need to set a and b, right? So in this case, let me put example specifically. So dv dt is simply say that 2 minus b. Okay, so simple, right? So now at that point, for example, this point is t is a 4. I mean, t equals 4, right? And then v equals 2, right? So that dv dt is going to be 2 minus 2, which is 0. Right? Okay. So dv dt is 0. It means that what? Slope of v of t is 0. Let me use other one. Okay. So 0 right here. 0. So we just draw the short line segment representing slope of v at t equals 4 and v equals 2. Okay. Okay, but actually look at the right-hand side of differential equation. So yeah, so here there is no t is involved in the right-hand side differential equation. So, no matter what you pick the t value, the slope will be determined by the value of v, right? Because of the right-hand side. Okay, just additional information. Okay, anyway, so for for any value of t when v equals 2 at this line, we're gonna get the just flat the line segment because dv dt gonna be 0, which means the slope is 0, like this. And then when v equals 1, right? Then what? In this point, then t equals 4, 4, right? And then but v equals 1, so dv dt is what? dv dt is going to be 1, right? 1. Because of 2 minus 1. Yeah, you may say that what is a VO4? I don't know, but you can see that, I mean, VO4 is what? We don't know definition of VO4, but we know that v equals 1 at t equals 4 right here at this point. Okay, so we don't know this, but we don't know the the formula for v of v, but v is what we are given is v equals 1 at here. So so we got 1, this slope is 1, like this, right? Sometimes like this, and like this. Keep doing that, what? And then v equals 3, then we're gonna get 2 minus 3, which is minus 1. So slope is like this. We drew. Okay. So I think hold on. So for example, maybe the graph of the unknown function v of t maybe like this, okay? And then what we got is this. At this point, the slope of the v of t is the minus 1, okay? So we just figured that we figure out the piece by piece of the graph of unknown function v of t. Okay. So it makes sense, So when you draw this, then we can see that the solution curve probably like this. I mean, like that, like this, like this. Okay. And we don't know exactly, but roughly graph of VOP must be like this. So all graph solution curve approaches the horizontal line v equals 2. Okay. This kind of curve, I mean this, for example, like this one. This kind of the line is called the asymptote. Asymptote. So in English, this is in Korean is 점근선, right? So asymptote. Okay. So then you may wonder that why so many solution curve right there. I thought every single differential equation there is only one solution. Yeah, the answer is no. It could have a multiple solution. Why? Yes, exactly. So the solution will be determined by initial condition, not only differential equation, but also initial condition, because there is no initial condition given right here. No initial condition given here. That's why we're gonna get multiple, a solution curve. So these are determined by specific value for initial condition. Okay. So now move on. So yeah, so that kind of curve, by the way, the name is so this kind of curve is called the inaugural curve. Curve right here. Okay. And then this kind of plot and figure is called the direction field. Okay. Except for inaugural curve, okay, except for inaugural curve, and then the figure consisting of the just short line segment, bunch of the short line segment representing slope, that is called the direction field. So when you give me a second. see. Hopefully it works. Oh, not this one. Sorry. 3. Yeah, because I made the code for plotting direction field like this. Okay, so there is a code right here. Okay, so you can download it. Yeah, so this one, you see that right there. Example 1.1, the differential equation, exactly what we got in the previous, example. So we define the function f, which is right-hand side differential equation like that way in MATLAB. It's called the handle function. Okay, so t and v, you see it at and the open parenthesis. Parenthesis means while, okay, in Korean. So t comma b. So it means that we designate t and v as the variable. Okay. So now and then step size of 0.25 and the t and v, we define the range of t and v. Okay, and then we draw the mesh grid. This mesh, we just set the mesh point. Okay, and then we using that command, the quick, QUIVR. Okay, so this is the command to plot the vector field. But yeah, I know this is one of the vector field, but specifically in differential equation is called the direction field because that one give us the information of direction of the solution curve. Okay, so just if you have time, just take a look at it. Okay, it's so cool. Back to here. All right, so now next one is the using this one, we can build up the method for finding solution graphically. It's called the isocline method of isocline. Okay. Okay. Probably I just skip the a couple of example in textbook, but you should look at the examples in textbook, okay, by yourself. Okay. First one, I'll introduce new terminology is called the autonomous. So differential equation dy dt is the f of t comma y is autonomous. Right here, autonomous. Okay. What do you mean that? What does that mean? It means that autonomous means that, right, f of t comma y only depends on unknown function. Okay. So if f of t comma y does not depend on the t, here t is what? Independent variable, right? Okay. If you read the textbook 1.1, 1.2 already, then you know about this, right? Does not depend on independent variable t. Okay. The derivative right here. Okay. So what does that mean? So it means that what? Dy dt is just f of t, f of y. Sorry. Okay. Y. Okay. So we already got the example of this one, autonomous. This one, that example is autonomous, right? So right-hand side does not depends on the independent variable t. So what's why this matter? Because in autonomous, if differential equals autonomous, then when you draw the horizontal line, then for each horizontal line, we're gonna get same slope, right? Same the slope of the short line segment. Okay. So right here, uh, mm, Well, here's a problem then. How can you figure out the the line of the slope if the differential equation is not autonomous? Okay, think about this. A differential equation is not autonomous. I want to figure out the line that contains same slope of differential equation, same slope of the unknown solution. How can you figure out that? That's the question. Anyone can answer that? First one, here's a answer. There's a question right here. Answer is, we want to find out the dy dt. Oh, no, chord is called isocline. Dy dt is constant, c. Because c represents constant, okay? So find a chord is called isocline, which dy dt is constant. So example here. Think about this. dv, so dv dt is 2 minus v right here. Oh, let me give other example. This v, oh no, v plus t, okay? So because we got 2 minus v. 2 minus v is what? Autonomous, right? So we want to figure out the chord or line, which are called the isocline, such that slope is constant, right? So this is non-autonomous, right? Because the right-hand side is function of v and t. Okay. Then we want to find out v and t such that this one equals dv dt is c, right? We're gonna find the chord such that dv dt equals c, but c must be equal to what? That must be equal to v plus t, isn't it? So we said this one, c equals v plus t. So now we're gonna draw the line. Okay. This is a t, and this is v. And then we set c equals 0, and c equals 1, c equals 2, and so on. When c equals 0, we're gonna get this. That v plus t equals 0, right? So we're gonna from here, from right-hand side, we can figure out the slope of v, right? So and then this one is nothing but just the linear equation of v and t. So v equals minus t, or v equals, that means what? V equals minus t. Just the line, right? This one. We sorry. Why keep doing this? Come on. Anyway, right here. Okay, sorry. I don't know why. Okay, so now right here, c equals 0. It means the slope is 0, right? 0, 0, 0. Just draw the short line segment. 0, 0, 0, 0, 0, 0. Okay. So by the way, that kind of line is called the isocline. Okay, it's isocline. And then now here, v plus t equals 1. You got it, right? So it means that what? This is a v equals minus t plus 1, which means that we just move parallelly, we move that line to up 1 unit. Then we got this. And here in this line, dv dt is constant 1, right? So 1, so graph is 1, like this, 1. Okay. 1, like that. And then when c equals 2, then what? v plus t is equal to 2. So then, yeah, you got it, right? So now I'll do this, draw that, and then draw this, and then draw that. And then you see the graph is just going to be up, maybe 2, right? This is the minus 1. I think it's the same as this one, I think. the -2 slope, slope. So now what? Guess what? Graph is I think is what? Trying to draw the integral core, which is solution core, must be something like this, like that, like this. Okay, like this. This is integral core, or we can say solution core. Okay, why that matter? Yeah, so this looks easy, right? But look, by drawing this kind of core, integral core or solution core in the direction field, we can figure out the solution of the differential equation diverge or converge, and also stability too. So we'll talk about this one in a chapter, I think, chapter 5. Okay, we'll talk about it. We're gonna back to this one direction field in chapter 5. Okay, so anyway, so that's the I just introduced the direction field. Okay, so give me a second. Hold on.